Welcome to the lecture series on soft computing in computer science. The last topic we have discussed about fuzzy rules as well as fuzzy reasoning, and these two topics are very fundamental to the heart of the fuzzy expert system, that is fuzzy inference system. Let me go into the topic to illustrate and to explain the idea behind the fuzzy inference system. What is fuzzy inference system? First of all, it is a framework that is needed and that is very well essential to compute certain things. What it is going to compute? It is going to compute the set, fuzzy rule as well as fuzzy reasoning mechanism. So overall, if I put together, a fuzzy inference system is a computing framework and it works based on the principle of fuzzy set theory, fuzzy if then rule as well as fuzzy reasoning. And this fuzzy inference system may also called by the name fuzzy rule based system, fuzzy expert system, fuzzy model, fuzzy associative memory, fuzzy control, fuzzy system. In all the names we can call this fuzzy inference system. Of course, there is a distinction, there is a different little minor difference between these terms, but anyhow collectively this fuzzy inference system can be called by some other forms of name also, fuzzy rule based system, fuzzy expert system, like that and all. But what is exactly a fuzzy inference system is, this is the exact computing framework. What about the other things like identification of the variable, partitioning the variable into linguistics, and then assigning the membership functions, forming the if then rules, all are some preliminary steps, all are some pre-processing kind of things to fed into this computing framework, and this computing framework only accept all these things and do the computational part to derive the conclusion. So that is why this fuzzy inference system says that it is the central part of the fuzzy system and it is meant for computation of all the set of things, right. And major components of this fuzzy inference system is rule based, and this is nothing but the set or collection of if then rules, and database, and it is nothing but collection of MF membership functions, and finally inference engine. It is nothing but a reasoning mechanism which performs the task of inference procedures. So this is the what you have to tell about. There are three components in fuzzy inference system: rule base, database, inference engine. We are going to deal with these three things. So before getting into it, we need to know, since I said it is a computing framework, what are the steps of the computation in a fuzzy inference system? What are the steps? The step 1 is fuzzification of inputs. Whenever you derive input from the data or from the system, the first step before constructing a fuzzy system is the fuzzification of input. Followed by that, you should do three major steps, and these major steps are the computing framework role. First one is application of fuzzy operator, second one is application of implication method, third one is aggregation of output. So these are all the three major steps, and these three major steps forms the computing framework, and this computing framework works based on the principle of fuzzy set theory, fuzzy reasoning, and fuzzy if then rule. And last but not least, what you should do is the reverse process of this step 1. In the step 1, you will get the GRISP value, and the GRISP value is specified, and in the last step the fuzzy value is converted into GRISP. So entry is GRISP, exit is GRISP. In between that you are doing the fuzzification task. After doing the fuzzification task, you apply all the necessary computing ideologies like apply fuzzy operator, apply implication method, and aggregate all outputs, then followed by defuzzification. So this is what the computing framework says all about, and all these are based on fuzzy set theory, fuzzy reasoning, as well as fuzzy if then rule. There are three models that are available. You can, like a ready made, it is available, this computing framework. You can plug and play this model into your proposed system, or you are aiming to develop a fuzzy system for any engineering problems. So there are, those models are named after the scientist. Mamdani model, Takaki, Sujino and Kong model, Tsukamoto model. And these three models have its own inference procedure in order to give a definite conclusion over the set of conditional statements. So, we are going to deal with how the Mamdani system is working with two different principles. One is max min composition, another one is max product composition, and how this Takaki, Sujino, Kong model and Tsukamoto model is. And based on the nature of problem and based on the kind of conclusion you are about to derive, you can choose any one of the model, right. Let me explain each and every model one by one, and having a thorough understanding based on the idea of the model as well as the difference between each and every model. It is your thought process to decide which model you should go about for a kind of data or for a kind of problem, right. First, Mamdani model. So, we have already discussed about the kind of inference mechanism, that is the reasoning mechanism with the single rule and single antecedent. So, that is the thing here. So, this is one rule and this is another rule, right. We have two rule system here, right. So, if x is a1 and y is b1, then z is c1. If x is a2 and y is b2 and z is c2, now you want to do it, right. So, already what is this kind of rule? It is a multiple rule with multiple antecedents. So, that is the rule condition. Now, my inputs are x and y, these are my inputs. So, these are all my rules and these two are all my inputs. Now, if I submit my inputs and if my inputs triggered the rule, all rules are simultaneously executed. If all the rules are simultaneously executed, see, this x has the cut point in a1 here and a2 here, and this y has a cut point b2 here and b1 here, right. So, now I have to draw a parallel line, I have to draw a parallel line, right. So, this is the idea, I have to draw. When I draw a parallel line, this line cuts here and this line cuts here, this line cuts. But what I have to do here, I have to take min value. Remember our previous presentation that dealt about fuzzy reasoning, right. So, this fuzzy reasoning, that is you have to take the minimum value. If you take the minimum value, only I have to decide this dash. If I take the minimum value, only I have to decide this. So, this is C1 and this is C2. From C1 I have taken C1 dash as well as C2 dash. Now, what I want to do have? I want to have C dash. So, according to the fuzzy reasoning mechanism, I have to take the max value. So, this is what max min composition. So, I think you understand the idea how the Mamdani system is working. So, it is nothing but it is equivalent to the fuzzy reasoning mechanism, multiple rule with multiple antecedents. So, that procedure is being dealt again here as a Mamdani model. For each and every input value, all the rules are fired, corresponding cut points have been taken. Overall, the corresponding cut points you do take a minimum value, and from the minimum value finally you should take the maximum value, right. Next, max product. So, here also the same. See, I have rule 1, I have rule 2. For rule 1, for a member variable a1, I have take a bell shaped curve, as well as for a member variable b1, I have take a member shaped curve, as well as for a1, I take a bell shaped curve and a bell shaped curve like this. So, my rule is like this, my rule is like this, right. Now, I wish to know for the given input value x and y, for this given input value x and y, how the rules are fired and what value we have derived, right. So, if you take that case, x1 is here and for in a1 and a2 is here, and for y here is here and here it is here. Now, if I take the here, if I take the corresponding value, if I take the corresponding value, now I want to take the product of this value. In the previous case, among the two I have taken the minimum, but here I have to take the product, see the product. So, I have to multiply this value with this value, with this value, I have to take a multiplication. Likewise, I have to take a multiplication of these two values, that is product, I have to take the product. Then the product value C1 dash and I have C2 dash. From C1 I have a C1 dash and C1 dash is nothing but the product of these two values. From the C2 I have a C2 dash and C2 dash is the product of these two values. Now what I have got? I have this value, I have got this value. Over this value, I to take a maximum value. See, that means I to take a union. Maximum value, simply speak, C2 is lesser than C1 dash, right? C2 dash, C1 dash. So I have to take C1 dash. This is not the case. So max here refers to I have to take the, see the curve. C1 is also taken out and C2 is also taken out. So I have to take the maximum value. So it means that I have to take the union of both the C1 dash as well as the C2 dash. So this is what Mamdan. So the only difference between the max min composition as well as max product composition. Remember how we performed the max min composition, max product composition in the last presentation but previous presentation, in the fuzzy reasoning mechanism as well as fuzzy rule of inference as well as fuzzy conditional statements, those kind of steps. And in the previous presentation also we have discussed about the max min as well as max product composition. That idea has been taken up here and it has been applied over these kind of ideas, right. Next, another model, Takaki Sujino and Saw model. Here he can either, see, same thing, he can either go for min or he can go for product. So same thing, but what is the thing that has been taken here? That is the major thing, So likewise I have a two rule, R1 and R2, I have a two rule, and these two rules are fired based on the input value, input 1, input 2, I have to, and the corresponding cut points have been taken, and over the cut points I have to take the minimum value. Here this cuts here and here this value cuts here, for which here this cuts here and this cuts here. I want to take either minimum value or product value, and this is treated as W1 and W2. Here instead of having the value as a singular, here we have got a function, because the nature of input variable as well as the nature of rule as well as the nature of environment, particularly with the respect to the problem statement, is like that. So we got Z1 like P1 X1, P1 Y1 and R1 plus 1 like this, over which we need to get the weighted average to calculate the Z value. So this is the idea of Takaki Sujino and the Kong model. And what is the limitation or challenges with this Takaki Sujino model is the consequent of each Fuzzy-Indran rule is represented by a GRIS function. So this is what I said, the consequent. See, instead of saying that if X is A, then Y is B, here both are fuzzy value. But in the respect to Takaki Sujino model, if you represent, this is represented as a GRISP function rather than the value, it is represented as a GRISP function. So that is the thing. In Sugimoto model, the same thing, R1 I have and R2 I have, same, the value is getting fired and we need to take the cut point value. After the cut point value I need to take that weighted average. I need to calculate the values of W1, W2, how it has been calculated, and I have to take the corresponding values and it has been cut where, and I need to find out the weighted average value. Finally the weighted average value is calculated like this, right, Z equal to W1 Z1 and W2 Z2 plus W1. So this is the Sugimoto model. So in this Sugimoto model, if you could see that the consequent of each Fuzzy-Indran rule is represented by a monotonical MF. So this you should remember when you start understanding the model, that is Sugimoto model. So when I want to say the Mamdani model, the Mamdani model has its own idea of understanding the rule of inference, followed by TSK model and followed by Sugimoto model. So overall, these three models where it is situated in the fuzzy inference system. So this is the one block where you are interested to dealt with before developing a fuzzy expert system, and this block is going to be called as fuzzifier block. And this is the another block, and I said that this block is the heart of the system that you are going to develop, and this system is the mainly dealt with the computing aspects of a fuzzy system. And followed by you have a separate block called defuzzifier, and one more important block that ignites, that triggers, that starts this fuzzy inference engine is knowledge base. So based on the knowledge base only the engine is driven and the engine get executed, and if the engine gets executed, overall the system gets run. So this is the perfect figure detailing about the expert system component of a fuzzy system, right. You have an input, the input is fussified, and that fussified input is fed into the inference system. The inference system get fired or get executed based on the knowledge base. Once the result is produced, the produced result is entered is a defussifier block, and the defussifier block will convert this output. So this input is crisp and this output is also crisp. In between that you have fuzzy value. So the entire system is working with respect to fuzzy value. This is what the functionality of a fuzzy expert system. Execution of a fuzzy expert system. How this fuzzy system is executed? See, simultaneous execution of all rules, or otherwise I can say that firing of rules. Rule gets fired, all rules in the fuzzy knowledge base gets fired for the input value. See, this is one rule, this is another rule, like that you can have r number of rules. For each rule corresponding value has been obtained and it has been applied to aggregator for we say collector. So you have to supply a gris value as an input, like I said, some x value or some y value you have to supply, and this x value and y value is subjected to rule 1, rule 2, rule 3 etc. up to rule r. For each rule what you have to take? You have to take the cut points. Of all the rules of the cut points, either you go for min value or product value. Then after that you need to find the max value in order to find the fuzzy value of C dash, and this C dash is fed into defussifier flag to get the crisp value. So the input may be crisp or fuzzy. Why? See, definitely is crisp, but you have a fussification flag. That fussification block will change that crisp value into a fussified value, and the final defussifier block will change it to a crisp value. So this is the complete execution scenario of a fuzzy expert system. Let me explain this, or let me more detailedly illustrate how this fuzzy expert system is executed based on the step that is illustrated. So when you want to construct a fuzzy system, you should remember the task. First step is fussification of inputs, and the reverse of the fussification of inputs is the fifth step, defussification. In between the step 1 and 5 you have the computing framework, and the computing framework will do fuzzy operator, implication method, aggregation output. So these are the three things that you should remember while constructing the fuzzy expert system. Defussifier. So the defussifier is the last block, and this last block will do the reverse process of what this fussifier block will do. It converts the fuzzy output, where we got fuzzy output in this juncture, you got the fuzzy output, and this fuzzy output will be changed into a crisp by means of this defussifier block. So what are all the ideas that are available in order to do this defussification? You have centroid of area, you have bisector of area, you have mean of maximum, smallest of maximum, largest of maximum. So you have 5 different ideas in order to get the crisp value from the fussify value by means of defussifier block. One is COA, centroid of area, another one is BOA, bisector of area, MOM, mean of maximum, SOM, smallest of maximum, LOM, largest of maximum. So this is what the functionality of the defussifier block. So this is mathematically illustrated as well as the pictorially represented. This curve, you should remember that after taking the max value. Once all the rules have been fired, individually the rule fired, the individual rule fired value can be taken with either min or product, right. You can go with either min or you can go with either product in order to find the W1, W2, W3 etc. and so on values, over which you can have C1, C2, C3 like that are values. After obtaining that individual rule fired value C1, C2, you have applied the max value, that is nothing but the union operation to get this kind of composition of all the C's of, that means consequence, where if I want to derive the final defuzzified output, that means crisp value, if I apply smallest of maximum, say for example smallest of maximum, this is bisector of area, smallest of maximum, this is, see, all of the all, this is the smallest of maximum, this point, largest of maximum, this point. See, this does not have any formula. See, this, if you take this entire curve, if you divide this entire curve into two half, this half containing the smallest value, this half containing the maximum value. See, here only I have the curve, I have the curve. This is the core. If you remember our initial presentation, core, alpha cut, beta cut, like that kind of value is there, right? So, smallest of maximum, these are the smallest area, these are the portion where you can find the smallest. In that smallest, the maximum value is this, right, because it cuts here. This is the portions where you can find, this is the portion you can find the maximum value. In that maximum value, the point where it get cuts, it is the largest of maximum. Then what do you need? You need centroid of area. The centroid of area is computed based on this expression, integration z mu a of z a z s divided by integration z mu of z of dz. And mean of maximum is nothing but integration of z dash z dz integration dz. And bisector of area, it is computed integration mu of z equal to bisector of area is mu of z dz. So, this is the way you should apply these three. So, these three are computationally obtained defuzzified value, and these two are just a picked up value from the value where it gets cut. So, this is the idea of defuzzification, and this idea will be helpful to derive the crisp value from the fuzzy value. So, in order to explain how this fuzzy expert system is working, let me illustrate with a simple example or a simple case study, tipping problem, right. Imagine I am running a restaurant and I wish to calculate, or I wish to know how much amount of the tip has been given to my employee, so that I can come to an idea of who is performing better and what sort of incentives I can given to them, right. So, I have two metrics for the people, those who are coming to my restaurant. One is the quality of service, another one is the quality of food, and each I have taken 0 to 10, and the output, that means what I wish to calculate, that is the tips amount may be 5% of the bill or 25% of the bill. So, what is my problem statement here? My problem statement is, given the quality of service as well as the quality of food at a restaurant. So, given these two values, I need to calculate what is the right amount, so to the tip to the right person. So, in a 10-point scale, I have these two variables, So, a customer is coming to my restaurant, he is taking food. While leaving from the restaurant, I have asked that customer to give the input based on the 10-point scale. One 10-point scale is meant for the quality of service, how the effective the service is by the employee of my restaurant, and how the quality of food by the employee of my restaurant. So, this is person who is responsible for cook, and this is the person responsible for serving the food, right, like waiter, we may say that, wait person. So, based on that, I can come to a conclusion that, say for example, if a person come with a family of 5 a member, and he took food for 1000 rupees, and if he feels quality of service as 9 as well as quality of food as 9, definitely how much amount he will pay? Maximum 25% of the bill amount, right. So, 1000 rupees if he consumed food means 250 rupees he paid as a tips. So, accordingly I can give the incentive for the person. Okay, this white person who served the customer in table number 8 or 9 will be the one who is receiving very good response from the customer, and he received more, and I can give some incentives or some additional benefits to that person. So, what I mean to say to you based on this tipping problem is, I am the owner of a restaurant and I want to develop an expert system, and this expert system will try to find out the tips amount based on the two input metric. So, accordingly I need to decide some other things in the future scale. What is the first, what are the variables that are available? The quality of service. The quality of service is, I can divide it into linguistics, poor, good, excellent. Quality of food, I can divide it into two metrics, rancid and delicious, tips amount, cheap, average, generous. So first thing, once you given the variable, the next important step is you need to derive the linguistic variable. Then you need to assign values for the linguistic variable, then you need to derive a rule. What are the rule says? If the service is poor or the food is rancid. Service is also poor, or on the other hand food is rancid, not so delicious, it is poor. So definitely sometimes we won't give tips and all, we will leave the hotel. So here I have mentioned that tip is cheap, maybe 5 rupees, 5% of the total bill amount if we consider food as for 100 rupees. So that's, so likewise you should understand the rule. So how this rule is get executed? So I have all the rules are simultaneously fired. I have two input values, the two input values are any value between 0 and 10, the rules are fired simultaneously and the values are aggregated and then the output is calculated. So the inputs are crisp, limited to a specific range, all rules are evaluated in parallel using the idea that we have discussed in the concept of fuzzy reasoning, then the results of rules are combined and defussified to produce the result. So this is the 2 input, 1 output, 3 rules fuzzy system. What is the first step? Fussification of inputs. If I give any value, say for example if x equal to 8, I have to say where this x is 8 is kept. See, x equal to 8 means 0 to 10 scale, the customer has given the value as 8. If the customer has given the value as 8 means it is more on the delicious side, so food. So the result of defussification is 0.70% or 0.7 probability, right. So likewise I need to go for service equal to 3. So 0 to 10 scale, if I give this, service is poor. So excellent, it is very low, service is poor, right, and delicious it is very high. What is the amount of tip? So the two cut points has been taken and what operator I have to apply? I have to apply here max, if it is a max min composition, apply R operator, So I have to take the result, I don't know, apply fuzzy operator. Then what I have to apply? Apply implication operator. So we have decided. So over this value, what I have to take? The result of implication. So since all the rules have been executed, based on the idea I have to apply the min operation. So the result of implication is this. So the first thing is apply of operator, that is the R operator, that is a max, that means a union. Here the consequent operation is. And overall all the rules I have to take. See, like this I have fired all the rules, where the cut points, or how the rules get fired, where the cut points, So I fired all the rules. See this one, C1 dash, C2 dash, C3 dash. Overall I have to apply what? Max. So here I can apply implication method. This implication method may be either min or product. Here I can apply the fuzzy operation, it may be either max or min for each individual rule antecedent in the consequent. So in the antecedent you should take the max value, in the consequent you should take the min value. Overall you have to take the aggregation, you have to take the maximum value. So these are the 4 steps and these are the complete process, and after applying the application process you should defussify the value. The defussification value, here it is taken the centroid method, the centroid method takes this value and it is found to be. So it means that if a customer leaves the restaurant and if he consumes food for 100 rupees, and if I ask what is the value for service and what is the value for food, for service the person has given the value as 3 in the point scale of 10, for 8 the tips amount is 16.7, approximately 17 rupees the tips amount. So accordingly I can give incentive, accordingly I can rate the performance of my employer, so I can do such things. So with this I stop this idea about explaining the fuzzy expert system. In the following lectures I will present still more case studies in order to understand how this concept of fuzzy expert system can be applied over various other domain problems to give a better clarity about the development of fuzzy expert system.